Welcome students. Here we will see a very important question from the topic sum of n terms of an arithmetic progression. So first of all, let us see the question. Here question is, if the ratio of the sum of m terms and n terms of an APB m square is to n square. Ratio of sum of n terms and n terms is given, which is m square is to n square, where m is not equal to n. Prove that the ratio of its mth and nth term is 2m minus 1 is to 2n minus 1. Okay, so let us see the solution here. Let first term be a, let a be the first term, let a be the first term and d be the common ratio of the arithmetic progression. Okay, and what is given here? Here given that the ratio of sum of m terms means Sm upon sum of n terms Sn. This is given m square by n square. Okay, and by the formula, we know the formula Sn is equal to n by 2 2a plus n minus 1 into d. So by using this formula here, Sm can be written as m by 2 2a plus m minus 1 into d. Similarly, Sn is, this formula can be used here, n by 2 2a plus n minus 1 into d. Okay, and this value, this ratio is given m square by n square. This is equal to m square by n square. Now let us simplify it and try to get a relation between a and d. Okay, so when we divide both sides by m upon n, then what we get? See, dividing by m upon n. Here m by n will be cancelled out. Since we are dividing by m by n, so m by n will be cancelled out, as well as this half will also be cancelled out from numerator and denominator. So here we are getting simply 2a plus m minus 1 into d upon 2a plus n minus 1 into d, and this is equal to m by n. Okay, since we have divided both sides by m upon n, so 1 m by n is cancelled out, 1 m by n will remain here. Correct. Now further we will simplify it by cross multiplication. Okay, so if we multiply this relation by m, what we are getting here, m into this much is 2a into m plus n minus 1 into d into m. Similarly, by cross multiplication, 2a into n plus m minus 1 into d into n. Correct. Now we will keep a in one side and d another side. So if this 2an will be transferred to left hand side, and taking 2a common, we are getting here m minus n is equal to transposing this term to right hand side. Okay, so and d will be common, so here m minus 1 into n, and this term transferred to right hand side, n minus 1 into m. Okay, correct. Now let us simplify this expression inside the bracket. So this is 2a m minus n, this is equal to d. We take one step here also. This is d m into n minus n minus m into n and plus m. minus mn plus mn is cancelled out. So we are getting here m minus n, correct? And therefore, you see here m minus n is common in both the sides. So this will also be cancelled out. So we are getting d is equal to 2a. We are getting this result. Correct? Relation. Not, of course, this is not the final result. This is the relation between first term and common difference. Correct? Now you see what we have to find out. Prove that the ratio of its mth and nth term. So we have to find out the ratio between mth and nth term. By the formula, this is a plus m minus 1 into d. We are using the formula for nth term of an AP Tn, which is equal to a plus n minus 1 into d, a plus n minus 1 into d. By simply putting the value of d, will get the result. So this is a plus m minus 1 and d is equal to 2a upon a plus n minus 1 d into 2a here. And this is equal to, again a will be common. A will be common from both the terms. So this is 1 plus m, okay, minus 2. Correct? In denominator also, if a is common, 1 plus, sorry, here this will be 2m minus 2. Similarly, if a will be common, we'll get 1 from here, and here 2n minus 2. 2n minus 2. This a will be cancel out, and here we are getting 2m, and minus 2 plus 1 is minus 1. Similarly, in denominator, we are getting 2n minus 1. In denominator, we are getting 2n minus 1. So this is the result. Ratio of mth term and nth term is 2m minus 1 upon 2n minus 1. This was we had to proved here. So we are getting this result here. So it has been proved. Simple question, little bit tricky, but we can understand it. We can do it very easily. Thank you very much for watching this video.